So in circles, today we are going to talk about tangents to a circle. Okay, so let's understand what is a tangent. So let me draw a circle here, right? So we know this is a circle. So if I draw a line, for example, a line XY here, which is not touching the circle, right? What happens if I draw a line here? This line is passing through the circle and dividing the circle into two parts. So this line XY is called as secant. Secant to the circle. A secant is a line secant is a line that divides the circle into two parts. Then what happens if I draw that line which just touches the circle at one point, right? So XY. This line is nothing but tangent to the circle. Okay, this line is nothing but tangent to the circle. So basically, there are two new terms that we are learning today. So one is a secant, one is tangent. What is secant? Secant is a line which divides the circle into two parts. Okay, and then tangent. Tangent is a line which touches the circle at one point. Okay, which touches the circle at only one point. That is tangent. Now, what is this? So this is a circle, right? So if I just draw a line, if I just draw a line here, so what is this line? This line which touches the circle at 2 points. Okay, the line segment which touches the line, which touches the circle at 2 points, that is called chord. Okay, a secant is a line that can be beyond the circle, but chord is a line that touches the circle at 2 points, and that line resides within the circle. So that's a chord. So chord can divide the circle into two parts. This is first segment and this is two segment. So a chord can divide the line into the circle into two segments. Now, what is the biggest chord in the circle? So this is also a chord. And if the center is here, if a line passing through the center of the circle, that will be your biggest chord. That is nothing but your diameter. Okay, the biggest chord in a circle is a diameter of the circle which passes through the center. So it need not to be a horizontal line. It can be like this, right, which passes through the center of the circle, or it can also be like this. So that means how many chords, the biggest chords or diameters we have in a circle are? There are many, infinite, right? From this from the center of the circle, we can draw a number of lines that can pass through the center of the circle, and every line that passes through the center of the circle is a diameter. That is the biggest chord. Okay, so the biggest chord is a diameter. And what diameter does? Diameter divides the circle into two equal halves, right? So diameter divides the circle into two equal halves. Divides into two equal halves. What are those equal halves are called? Those equal halves are called as semicircle, right? So in a circle, right? Let's say this is a circle, and this is the center of the circle. Then this is the diameter, and this divides the diameter divides into two equal parts. So each equal part is called semicircle. Understood? Right. So these are all the concepts that you require to get into further into this circles chapter. So what we learned here, what is a secant? Secant is a line which divides the circle into two segments. And then the line which touches at one point on the circle is a tangent. Okay. And then we learned about what is a chord. What is the biggest chord? Chord is a line segment which divides the circle into two segments or two parts. So the biggest chord is a diameter, and the diameter divides the circle into two equal halves. So each half is nothing but our semicircle. Okay, so those are the concepts needed in here. And now let's get into, there is a theorem here in this chapter, right? So theorem 10.1, that is the first theorem. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, so let's see what this theorem is saying. So if we draw a circle, right? If we draw a circle, the tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, let's say this is the center of the circle, that is O. Let's say this is the center of the circle O, and I am drawing a line, I am drawing a tangent at this point, for example, right? So this has to touch the circle at one point. Okay. Let's say I'm drawing with free hand, so bear with me. So this is X and Y. So this is the tangent XY, and this is touching the circle at one point. Let's say that point is E. Okay. So if I draw a line here, this is OP, right? Now, what this theorem says is the tangent at any point of a circle is perpendicular to the radius through the point of contact. So what they are basically saying is this angle between the tangent and the radius joining that point on the circle is right angle 90 degrees. Okay, let's see whether it is true or not. So if I put any point Q here, right? For example, let's take a point Q. And if I just draw an imaginary line, right? OQ. So now if you look at the behavior of Q, so this Q point can be anywhere on the tangent. That can be on this side as well, right? This side or that side or anywhere. So what I can observe here, so OQ is greater than OP in most of the times, right? Most of the times it is OQ is greater than OP because this is the radius and OQ is up to this point it is radius. So OQ is little bigger than that. So what I can say is OQ is always greater than OP except at one point where if this Q is moving to this side and if P becomes Q, right? When P is at point Q, then what will happen? OP becomes OQ. So there is one scenario where the radius of the circle and the point on the tangent are equal. That is radius. So that point, there's only one possibility. That possibility we can say when P and Q both are equal, that's the radius. So this when we have this radius equal to OP or OQ, at that time we can say this OP or OP or OQ are perpendicular to the tangent, which is XY. Can I say that? There is only one instance where this tangent becomes perpendicular, that is at the point of radius. So when OP is equal to OQ, at that point it is perpendicular to XY. So this is the theorem, and this theorem will be helpful in resolving the problems that we will see. So what is the thumb rule from this theorem? The tangent of a circle which touches at point, wherever the point it is touching, that point is perpendicular to the line joining the center and that point. Okay, so that's the thumb rule from this theorem. Now let's move to next, right? So here, this is your exercise. So let's see what kind of problems or questions can be asked here. How many tangents can a circle have, right? So how many tangents a circle can have? On a circle, there may be n number of points, right? So you can have here, you can have here, you can have here, like that. If this is here, I can say this is one tangent. If it is here, I can say this is another tangent. And if it is here, I can say this is another tangent. Likewise, how many tangents we can have? The number of points on the circle. So we can say infinite. So we can have infinite number of tangents on the circle, but each tangent touches at only one point on the circle. Fill in the blanks. Okay, a tangent to a circle intersect it in dash points. How many points it intersects? At only one point, right? That's what we learned. A line intersecting a circle in 2 points is called a line intersecting a circle in 2 points. So what was that? Secant we learned, right? That's a secant. Then a circle can have dash parallel tangents at the most. Okay. So how many tangents, the parallel tangents that a circle can have? Let's say this is one end of the circle and this is another end. So parallel tangents means it has to be exactly at the opposite side of the circle. That means a maximum we can draw two parallel tangents to the circle. So how many? Two parallel tangents. Similarly, the common point of a tangent to a circle, the common point of a tangent to a circle and the circle is called where it touches the point of contact of the tangent. Okay, so that point is called the point of contact of tangent. Then a tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at a point Q so that OQ is 12 centimeter length of PQ. Yeah, length of the tangent we will discuss in next. Okay. And what is the next one? Draw a circle and two lines parallel to a given line such that one is a tangent and the other is a secant to the circle. Okay. Yeah, that's a simple, right? So this is a circle. They're asking you to draw two parallel lines. One is a tangent. So this is a tangent. And another is a secant. Yeah, draw some parallel line. This is a secant. Let's say this is xy. Xy is a tangent. And let's say x dash and y dash. This is a secant. Okay. So likewise. So when we know the concepts, like what is a secant and what is a tangent, we can answer all these objective or any questions that they can ask. Okay, so that's about the basics of tangent. So that's all for today's session on the circles and the tangents. I hope you understand, you understood the topic, and I will see you next time. If you have any doubts, please contact me through my Urban Pro profile. Thank you.